Okay, addition and subtraction, two of the most straightforward, basic first operations you ever learn. Um, but often when we just think we understand something without really understanding it carefully, it makes things a lot harder than they have to be. Addition could just mean continue to count. That's what we were looking at with the stars last time. Right? I've got 3 stars, 1 star, 2 star, 3 stars, plus 1 more, 4 stars, right? 1 plus 1 plus 1 plus 1. That's continuing to count. That's addition. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4. That's great. But it's hard to think about that counting dealing with non-whole numbers, either with negative numbers or with fractions or decimals or even variables. So we actually need a slightly better, more robust definition. So the definition I give for addition is addition means continue to move a specified amount in a specified direction. Back to the number line here. If I want to think about 3 plus 1, oops, I've moved 3. I'm moving an additional 1. And that's how I end up at 4. I go 3 steps to the right, plus 1 more to the right, that's 4. It's this direction business that lets us deal with negative numbers just as easily as positive numbers. I've got 0 here. I move to the right 3. I'm going to continue to move 1 to the left. I'm still doing addition. I'm continuing to move, but this 1 is actually in the other direction. So I've moved backwards closer to 0 to get to 2. Or I could deal with these numbers in the other order. I could start at -1. How do I get to -1? I move 1 space to the left. And then I'm going to continue to move, but instead of continuing to move to the left, I'm going to move to the right. I'm going to change direction now to the positive direction. From -1, move to the right 1, that gets me back to 0. To the right another 1, that gets me to 1. To the right another 1, that gets me to 2. Same value, 3 plus -1, -1 plus 3. That value is 2. And that negative is just telling me to the left versus 3 moving to the right. 3 to the right, 1 to the left here. Let me move these away from that lower problem. Right? Here the 3 and the 1 were both going to the right. If I want both of my values to move to the left, I can say -1, 1 to the left, and then continue to move in a particular direction to the left. How far? I'm going to move a distance of 3 to the left. So altogether from -1, -2, -3, -4. I'm going to end up at -4. As opposed to +4, if that 1, 2, 3 plus 1 more, 4, all moving to the right. Okay. Adding and subtracting is all about movement. use one-digit numbers just to make the drawing easier. Now, when we have a whole bunch of them here, it can get a little messy looking to have all of this movement. Left 3, right 7, right 6, left 2, left 5, forward 8. It looks like I'm ending up in positive territory, but that's assuming my arrows are somewhere close to what they should be. And it's kind of annoying to have to, okay, from 3, counting -2, -1, 0, 1, 2. Wait, how much have I counted already? That can be kind of hard. So we have another operation that lets us deal with that. And that operation is subtraction. Now, subtraction um, is actually used in a few different ways. So I'm going to give the most basic definition that goes along with the addition definition, and then we'll go a little bit further into it. So subtraction means continue to count, but in the reverse of a specified direction. So I continue to count a specified amount, same as addition, but in the reverse of a specified direction. And that's what's going on here with my -3 and my 7. If I'm looking at -3 plus 7, I could recognize it's the same as 7 plus -3. Addition's commutative. I'm adding those two things. The 3 is the arrow going to the left. The 7 is going to the right. So whether I go to the left first and then to the right, or go to the right first and then to the left, starting at 0, either way, I'm going to end up at positive 4. Right? We can actually count that. So -1, -2, -3. So from -3, -2, -1, 0, that's 3. 4, 5, 6, 7, 1, 2, 3, 4. Or from 7, 1, 2, 3, 4, 5, 6, 7, back up 3, 6, 5, 4. Now, if you're like me, this second example was much easier to deal with. Okay? 7 plus -3, I'm going to the right 7, backing up 3. Well, that's what 7 minus 3 means. If I were to continue to count a specified amount of 3, 7 plus 3, I'm getting bigger and bigger. But I'm not adding 3, I'm subtracting 3. I'm going the reverse of 3. I turned around, 3 is usually this way. Instead of that, I went 3 back the other way. And that's what we grow up understanding. That's the takeaway that we're used to. And that makes a lot of sense. So how do we deal with something like -3 plus 7? We recognize that it's the same as this, which is the same as this. And we do a subtraction. Let's dig a little deeper into that. If I have two numbers, each going in the same direction, say 1 and 3, that's the sum. That's what it means to be the sum. I'm getting 1 and 3 more. That's a total of 4. Or going in the reverse direction, back up 1, back up 3 more. That total is 4. So 1 plus 3 is 4. -1 plus -3 for in that negative direction. I can actually think of it as factoring out that negative. We'll get to factoring formally in a little while. I'm recognizing both of these are negative, so that total is negative. But if we start having numbers going in different directions, select the right tool here. Let's say go forward 7, then back up 3, or 7 plus negative 3, same thing, or back up 3 and then go forward 7, I can see that these are opposite directions. The 7's positive, the 3 is negative. The 7's positive, the 3 is negative. So for these, I'm recognizing that I want the difference. Either way, I'm ending up at 4. Now, what if my negative number is bigger? What if I'm at negative 7 and I add 3? That looks like an addition problem. But again, the 7 was going to the left, the 3 was going to the right. This is where absolute value comes into play. This is why we want to think about the magnitude and also the direction. This looks almost identical to what we had on the previous screen. I've got a big 7 and a little 3, a big 7 and a little 3, a big 7 and a little 3. 7, if I just take it as a block, 1, 2, 3, 4, 5, 6, 7. If I cut that block, try to make a straight line here. If I get rid of those last 3, how much is left? 4, right? 7 is made up of 4 plus 3 more. So if this is the 3, what's left is 4. I'm doing 7 take away 3 to get 4. I'm doing takeaway. I'm moving 3 less than that total of 7, but that takeaway is still leaving me in the negative direction. So here's our general rule. I don't want us to oversimplify things. A lot of you have been burned by tricks and oversimplification rules. Talking about a negative this and a negative that makes us something. We don't want to rely on those rules that are so easily mixed up, but we do want to have a way to think about this without having to actually draw it out and count it out every time, right? So if I've got two terms that are going in the same direction, I'm going to put them together and get the sum, whether that's 3 plus 4 to make 7, or negative 3 and negative 4 all together to make negative 7. If they're going in the same direction, that's going to be a sum. But if they're going in opposite directions, what's left is finding that missing part at the end, right? If they're going in the same direction, I'm getting more and more positive or more and more negative. But if I went really far negative and then back towards 0, my answer is going to be reduced a little bit. From 7 back down to 4 in the negative. Or from 7 back down to 4 in the positive. Or if I start out going positive and then go really far in the negative. Doesn't matter which one I started out as. I'm getting the smaller, what's left over from that longer number. That's going to be my answer, right? So different directions. And since on the number line we only have two directions, I could say opposite directions. I'm going to find the difference.